Okay, so we're going to split this up with a common denominator. And do you see that you get to do two problems? So that one problem is x dx, and the other problem is 1 over x dx. You guys see that? All right, what's the integral of x dx? X squared over 2. What's the integral of 1 over x? Ln of the absolute value of x, right? Okay, so once you get the antiderivative, okay, you take your answer, whatever it is, okay, so let me rewrite the answer. Okay, this will be your process. And you put a bar on it, and then now you worry about the limits, okay? So don't worry about the limits while you're doing the antiderivative. That will totally mess you up, okay? You do the antiderivative the normal way you do it, and then at the end you put a bar and put the limits in. All right, what this means, according to the first fundamental theorem, is first you plug in e, okay, then you plug in 1, then you slap a minus sign between, right? Okay, so first I'm going to plug in e, so that's going to be e squared over 2 plus ln of e. Well, the absolute value of e is just e, right? Because e is a positive number, okay? Then I'm going to plug in 1, so that's going to be 1 squared, so 1/2 plus ln of 1. The absolute value of 1 is just 1, because 1 is a positive number. Then I slap a what sign between? Minus, but make sure you understand, this is a minus the whole f of 1, so it's a minus this quantity. Now, on your exam, when I give you something like this, if you just leave it ln of e, I'll consider that unsimplified, and you'll get a point off, okay? What is ln of e really? 1. You need to know that. If you leave ln of 1, I'll consider that unsimplified, and you'll get a point off. So what's ln of 1 really? Do you know? 0. Okay, so this answer is e squared over 2 plus 1 minus 1/2. So it's e squared over 2 minus, no, plus 1/2. Okay, and that's your answer. You can combine common denominators if you like. Okay, any questions on the first problem? All right, let's go to the second problem. And let's look at this. If you had this on a test, okay, what approach would you do first? What would you do first if you had this on a test? You would make U-sub. So what would your U be? Okay, then du dx is 2x, dx is du over 2x. Okay, I replace two things. What two things do I replace? My u and my dx. So let me go ahead and replace them. Leave everything else the same. I ask myself the question, do my x's cancel out?
Yes.
Yes, okay. So that means I'm on the right track. Do you guys see I can take out a scalar? What scalar would it be here? Be careful, it's not 2, but it's 1/2. So this is 1/2 integral of du over u cubed. Now at this point, it should be an easy reverse power rule, or it should be something in your pink sheet. Which one is it? Easy reverse power rule. But you got to rewrite it first. Do you guys see this? So this u3 should change to what? U to the negative 3. Okay, so let me change it. Okay, now it's an easy reverse power rule. So you add 1, divide by negative 2. This is kind of weird because it's a 1/2. If I divide by negative 2, I'm really multiplying by what? Negative 1/2. I think that's a little bit easier because I have a 1/2 here. So this will be negative 1/4 times u to the negative 2 plus Charlie. Okay, and that is a great answer. It's just the wrong answer. What do you need to do? Put that u back in. Remember, the u was a social construct that you made up yourself, right? It doesn't even exist. We may not exist, okay? So this u is u squared, so it's going to be in the bottom. X squared plus 1 squared plus Charlie. And there is my final answer. Okay. Now I want to point out to you guys that if I can change something really small on this problem, and it changes the whole problem. So let me show you what I'm talking about. What if you have this problem? It's the exact same problem, but I take out that cube. What happens to this problem? What would you do first? What would you do first? U is equal to what? X squared plus 1? Okay. Then du dx is 2x, and dx is du over 2x. What do you substitute? Your u and your dx. But notice, when you substitute your u on the first problem, it wasn't the entire denominator. Now, time to wake up, Kevin. Now, when you substitute your u here, it's the entire bottom, right? So what does that cue you off to think? It might be an ln problem, all right? So this is going to be equals the integral of x over u times du over 2x. Do my x's cancel out? Why, yes, they do. So what I'm going to do is I'm going to pull out my 1/2, but now left inside the integrand, I have du over u. Is this an easy reverse power rule problem, or is it something on my pink sheet? It is something on my pink sheet. What is the integral of du over u? It's ln. So this is 1/2 ln of the absolute value of u plus c. And that is a great answer. It's just the wrong answer. You need to come back and put your u back in. Okay, and there is your new answer, or your right answer. Okay, I want to point out here that let's say I didn't recognize that this was on my pink sheet. Okay, and I say, you know what, I think I'm going to rewrite this. What happens when you rewrite this, if you rewrite it correctly, you'll see you add 1 and divide by ding, 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 and hopefully you'll hear the ln bell, okay, if you didn't recognize that it was an ln problem. Okay, Ruchi, you with me? Okay, so that's your second problem on your warm-up. You guys good? Okay. If I were doing this problem on the test, I would make this my u down here. I would say u is equal to 4 plus e to the 4x. I would take the derivative, and I'd say that's 4e to the 4x. I'd solve for dx. And I would replace two things. I would replace my u, and I would replace my dx. Okay, I would take a look at that and say, do my x's cancel out? Can I get rid of the x's? No. What this will end up being is du over u, I think 4u e to the 2x, or I think something like that. Okay, it doesn't, the x's are not going to cancel out. I still have this x here. All right, back to the drawing board. What can I do? Recognize that it's an arctangent problem. Interesting. Okay, if it is an arctangent problem, if I go look at my pink sheet, I'll see that the arctangent says this should be an a squared, oops, what's arctangent? Is it u squared plus a squared? Yeah, so a squared plus u squared, right on the bottom. So possibly it is an arctangent problem. If it is, that means my a squared is 4, and that means my u squared is e to the 4x, okay? If u squared is e to the 4x, what's my u equal to? E to the 2x. Why? Because e to the 2x squared is actually equal to e to the 4x, okay? Over here, my a is going to be 2. Remember, you can disregard the plus or minus here. You just take the positive numbers here, all right? And then what I do is I say, okay, I'm going to take this down just like U-substitution. So you take the derivative, which is 2e to the 2x. You solve for dx, which is du over 2e to the 2x. You substitute two things. Now be careful here. Now instead of making this whole bottom my u squared is represented only by this part here. Okay, so when I rewrite this, what I get is e to the 2x over 4 plus u squared times du over 2e to the 2x. Do my x's cancel out? Why, yes, they do. Okay, so these cancel out. They don't disappear. They cancel out to 1. And what I get is 1/2 integral of du 4 plus u squared. Are you guys okay that I pulled that 1/2 out? Okay, you got to pull all your scalars out, because what happens is what you have left, this needs to be an easy reverse power rule problem, or it needs to be something on your pink sheet. And if you have your scalar in there, then you won't find it on your pink sheet. It'll kind of mess you up. Okay, so I pulled out my scalar. Is this on my pink sheet? Do I have something on my pink sheet that says du over a squared plus u squared? Yes. So the answer to that, I know from my pink sheet, is actually 1 over a arctangent u over a plus c. Okay, that's something you have to memorize. But I already kind of assumed it was an arctangent. So with all these assumptions, I know that a is equal to 2. So all my a's are 2. and I know that u is equal to e to the 2x, okay, and then I'll let you take it from there, okay? And what other questions did you guys have? 27? Okay, so let's look at 27. So 27 is an integral from -1/2 to 0 of x over the square root of 1 minus x squared dx. All right. Any ideas on this problem? Let's avoid the limits now. Ignore them. Okay, so what would you make your u equal to? 1 minus x squared? Let's try it. If u is equal to 1 minus x squared, then du dx is negative 2x. Then dx is negative du over 2x. Okay, guys, always do u substitution first. All right, if this is my integral, I replace two things. I replace my u and I replace my dx. So this becomes x over the square root of u times du negative du over 2x. Do my x's cancel out? Yes, they do. Okay. So since my x's cancel out, what I'm going to do is I'm going to pull out the scalar. It's not a 2 scalar. You guys comfortable that it's a -1/2 scalar? Okay. And this will be du over the square root of u. At this point, it should be an easy reverse power rule problem or something on my pink sheet. Is it an easy reverse power rule problem? Well, easy is relative, right? How can I rewrite this square root of u? U to the -1/2 du. All right, so then I'm going to add 1, divide by 1/2. Is that right? Divide by 1/2. And if I divide by 1/2, that's really the same as multiplying by 2. So on this side, this just becomes -1 times u to the 1/2 plus Charlie. And there is my answer. That is a great answer. But it is a wrong answer. Okay, go back and substitute your u. Okay, remember my u is 1 minus x squared. And there is my answer. Okay, so now what I want to do is I want to put the limits in. So you work this just like a regular antiderivative problem. Do you guys see that this looked like it was an arc sine, but it turned out not to be an arc sine problem? You guys good with that? So be very careful. Again, I would recommend always do u substitution first. Don't just jump and think it's an arc sine or arc tangent problem, because it might not be. All right, what I'm going to do now is I've got the antiderivative, so here it is, okay? And what you do is you copy the antiderivative, whatever your answer is, and you put a bar, and then you just put your limits in. Is everybody good with that? Okay? So remember, the first fundamental theorem of calculus says that this is f of 0, the antiderivative plug in 0, minus the antiderivative plug in -1/2. So first what I'm going to do is I'm going to plug in 0. You see if I plug in 0, I get 1 minus 0 here. Okay, if I plug in -1/2, I get negative square root of 1 minus, guys, what's -1/2 times -1/2? Is that 1/4? Okay, so guys, remember what we're doing here. First we plug it in, and then we slap a what sign in the middle? Subtraction. So do you see it's a minus in this problem? What's the square root of 1? Is that an imaginary number? Square root of 1. No, it's just 1, okay? If the negative's inside, then you have a problem. But this negative is outside, so it's just -1 plus, okay? What's 1 minus 1/4? Is that 3/4? Okay, so this is your answer. You can simplify it a little bit by knowing that, knowing square root of 3/4 is the same as the square root of 3 over the square root of 4, which is -1 plus the square root of 3 over 2. And you can get a common denominator here too and simplify it. But I think I got a common denominator, but it's all the same thing. Okay? All right, you guys good on your homework? All right, let's go ahead and do a little bit of review. But let's just talk about our methods, okay? First of all, before you came in after the holidays, you knew how to do U substitution, okay? Whenever you work a problem, an integral problem, you always look first and you say, maybe I should long divide, or maybe it's a common denominator problem, okay? Now, you didn't always know right off. Actually, long divide, you can tell right off. common denominator, sometimes you work the problem, it doesn't work, then you're like, oh, I need to break it up, okay? You realize it's a common denominator problem. But no matter when you figure it out, you got to do it somewhere at the beginning, okay? And when we did U-substitution, okay, we started with some different U-substitution problems. So at first we worked with polynomials, okay? And that's when we first worked with U-substitution. I just gave you a problem, you know, this is a basic one, okay? You just took the integral of it, okay? Then we got a little bit more complicated, and I gave you some trig problems, okay? So cosine 3x dx, okay? Then, you know, we did some transcendental, so ln and e problems, okay? So maybe 1 over x plus 2 or something like that, ln and e problems. And then if you remember, you probably want to forget, but there's this thing called back substitution, okay? And that problem, you had to go back and substitute what your u was. And that problem looks something like that, okay? So those were the u substitutions that you talked about. Of course, there's some, you know, some little tricks we threw in there, but mainly this is what we did, okay? And then when you came in on Tuesday, we said, you know what, now you have your arc-trig problems, okay? And there's 3 types of arc-trig problems, okay? Basically, before you even do the arc-trig problems, you have to look at these first. You could possibly have to long divide first, or you could possibly split the problem into 2 fractions because of a common denominator, okay? But then we said, arc-trig is pretty straightforward. There's only 3 possible answers, okay? You could have an arcsine, right? You could have an arctangent, and then you just memorize these formulas. Or you could have an arcsecant. The arcsecant had an absolute value, okay? And then we said, you know what? The trickiest thing we could do in here is actually saying, on one of these things to make it work, you might have to complete the square. Okay, and that's a summary of all the things that you've learned so far. Okay, so you're pretty smart at this point. You may not feel smart, but you know a lot about integrals. Okay, and so today what we're going to do is I'm going to try to help you do some shortcuts. Okay, I'm going to give you some new problems and also help you do some shortcuts. Okay, and the reason we're going to do some shortcuts is because when we get into polar in a few weeks, the main thing in polars is not going to be solving the integral. So you need to be able to solve the integral fairly quickly if you can. Okay, so I just want to show you this problem here. If you make this your u, if you make your 4x your u, and it turns out to be something in your pink sheet. So, you know, the 4 is just a scalar, so let's not disregard it, but let's just pull it out, okay? Is cosine u in your pink sheet? If it is, you can do a little shortcut. And that shortcut looks like this. What's the integral of cosine u? Sine u. You just copy it down. And then what's the derivative of 4x? 4. You divide by 4, make sure your x's cancel out, okay? And you put that, you know, whatever coefficient you get, you put it there, and add this to it. Okay, so let's do some shortcuts. Here we go. If you make this your u, you make 3x your u, is this on my pink sheet? Yes, okay. What's the integral of sine u? Negative cosine u. What's the derivative of 3x? 3. So you just divide it by 3. You see the shortcut, okay? Another thing you could have said is there's really a 1 here, so you divide this by 3, and you could say it's a 1/3. Same thing, okay? All right, if this is my u, is this on my pink sheet? Is secant squared u on my pink sheet? Yes, okay, then you can do this method. What's the integral of secant squared u? Tangent u, you just copy it exactly like it is. What's the derivative of pi over x? Pi. Let's see how easy this is. Okay, this had a 1 in front of it, so essentially we just did 1 divided by pi. Okay, over here, if I made this my u, is there a cosecant squared u on your pink sheet? Yes, okay. What's the integral of cosecant squared u? Is it negative? Cotangent u, okay, and then divide it by your the derivative of 7x, which is, you guys comfortable with that? Yeah. All right, and let's look at this one. This one's a little bit harder because there are actually 2 u's. So if you make this your u and this, and they have to be the same, okay, is this on my pink sheet? Yes, this is on my pink sheet. So guys, what's the integral of cosecant cotangent? Negative cosecant u. Okay, so you just copy your u. Okay, what's the derivative of x over 3? 1/3. If you divide by 1/3, what are you really doing? Multiplying by 3. So you see how that works. Okay, so I'm trying to give you a shortcut. If you don't like this shortcut, then don't do it. Okay, but I'm trying to give you a shortcut because eventually we're going to have to work pretty fast. Okay, now what you need to understand is, like, if I had a problem like this where there are two trig functions, if I make this my u and I make this my u, if I make the argument my u, is this on my pink sheet? Do I have something on my pink sheet that says tangent cube secant squared? No. If it's not, then this is not your u. Okay? Then your u must be something a lot bigger. Does that make sense? It's not just your argument. It's your whole trig expression, some trig expression. Now, what I need to do is use some smarts here. I don't know if you noticed, but what we always did was we always divided by the derivative. Does that make sense? You always divide by the derivative, and then it cancels out. Your x's have to cancel out. So what I really want to do is I want to divide by secant squared. And I know the derivative of tangent is secant squared. So if I were smart, if I make this u tangent, then the derivative would be secant squared. Okay? And then what ends up happening, I mean, really what U-substitution is you end up dividing by the derivative. Okay? And when I divide by the derivative, the secant squared is going to cancel out. So what do I mean by that? Well, first of all, let me just very strongly encourage you to rewrite this. Okay? The students who don't rewrite this have a lot of trouble. Okay? This 3, I really don't even like this notation, but it's very common, so I teach it to you. But this 3 is actually outside of the entire tangent x. Okay? It's not just the x. So if I rewrote this, what I really have when I do u substitution is I'm replacing two things. I'm replacing my u and I'm replacing my dx. So this u is now u cubed secant squared x. Dx is du over secant squared x. And do you see my strategy? My strategy was make the derivative secant squared so that I divide by the derivative and cancel out. Okay? So to make that derivative secant squared, my u had to be tangent x. All right? Do my x's cancel out? Yes. Okay, so this problem becomes u cubed du. Is this an easy reverse power rule problem or something on my pink sheet? Yes, easy reverse power rule, right? That's u4 over 4 plus Charlie, which is my answer. Just the wrong answer. What do I need to do? Put in the tangent x. Put in what my u is, plus c. Okay, and you don't need to move that 4 forwards unless you just want to. Okay, and there's my answer. All right, if I had a problem like sine 4x, cosine 4x, do you notice if I made this my u, on my pink sheet, do I have anything that says sine u, cosine u? No, so that's not my u. You guys good with that? So the u must be something bigger. The u must be either sine 4x or cosine 4x. In this situation, it actually doesn't matter. It actually doesn't matter which one it is. What do you want u to be? We can work it both ways. Okay, so if you make u sine 4x, then you take the derivative and you'll get, remember the derivative of sine u, so let me just write this here. The derivative of sine u is sine, no it's not, it's cosine u times du dx, right? So this derivative is going to be cosine u times what? Times 4. Okay? And then you solve for dx, so dx is equal to du over 4 cosine 4x. And I'm going to replace two things. What two things do I replace? My u and my dx. Okay, Jamie, are you awake? So this is going to be sine 4x is now my u, cosine 4x times du over 4 cosine 4x. Do my x's cancel out? Yes. Okay. What scalar can I pull out? Okay, 1/4 integral of u du. Okay. I think that's right. All right. And is this a problem that I can do? Yes. Okay. It's an easy reverse power rule. So it's 1/4 times u squared over 2 plus Charlie, and that's my answer. Okay. It's just the wrong answer. You need to go back and put your u back in. So that's sine 4x squared plus Charlie. And there's your answer. I got to warn you on this. You ready? Charles, are you with me on this? And Walker? If you made your u equal to cosine 4x, you would get a completely different answer. I'm just warning you, okay? It's still the right answer. So just FYI, integrals don't have unique answers, okay? You could have different answers from your friend, and you could both be right, okay? I'm just letting you know. Now, you can test it, though. When you get your answer, if you take the derivative of this, you should go back to here. Does that make sense? So if you and your friend have different answers, take the derivative of your answers. If you both get this integrand, then you're both right, okay? All right, so I wanted to show you that. And then I wanted to show you some shortcuts for e to the u. And then I'm going to show you some problems that are a little bit tougher and you need to know how to do. Okay, so remember the integral of e to the u is actually e to the u. It's been a long time, but that's what the integral of e to the u is, okay? But really, this is the integral of e to the u du. So if you look on your pink sheet, that's what it's going to say. If you do pattern recognition, though, what you're doing is e to the u dx. And that answer is actually e to the u divided by du dx plus c. Okay, so those of you guys who have been doing pattern recognition, what you do is you just copy your e to the u and divide it by the derivative of your exponent. Does that make sense? So let's do some easy ones here. Right here, if I think that this is an e to the u problem, all I do is copy e to the u and then divide it by what? What's the derivative of 3x? Okay, so there's a shortcut here. If you feel uncomfortable with it, then don't do the shortcut. But I'm just trying to help you to go a little bit faster. If I thought this was an e to the u problem, okay, what I do is copy the e to the u, okay, then I divide by the derivative of u. Okay, where's my u in this problem? Right there. What's the derivative of u? 15x squared. You divide by 15x squared. Your x's have to cancel out. Do my x's cancel out? Yes. So this becomes 1/5 plus c. Okay, so there's a few shortcuts you can do that will save you some time. You got to do it right, and the x's still have to cancel out. Okay, if the x's don't cancel out, it doesn't work out. Okay, on this one, we didn't have any x's. There's a 1 here, and you divide it by 3, and you didn't have any x's, so it was a moot point. Okay. Now, this is what I need you guys to write down, make sure you understand it. Okay, please write this down, this problem here. Okay, this is one of your tougher problems. Okay, if I did this problem, I would make u equal to 8 minus 2x minus x squared. Then I would take the derivative, and what I would get is negative 2 minus 2x. Then I would solve for dx. I would get du over negative 2 minus 2x. I would substitute two things, and what I would get is 1 over square root of u times du over negative 2 minus 2x. Then I would ask myself the question, do my x's cancel out? Do they? No, this is not the way to do it, okay? So I have to say, okay, my u must be something else. My u must not be this, okay? And guys, your u is rarely ever this. So don't put the square root. I mean, you could try it. It's going to turn out to be a big mess. Okay, u is rarely anything with the square root in it. Okay, might be sometimes, but very rarely. So what I'm going to do is this, and I'm going to complete the square down here. Okay, and I know you guys haven't had a lot of practice completing the square, so I'm just going to pull this down and I'm going to do it with you. This is my polynomial. I'm going to rewrite my polynomial. You guys agree with that? Okay, you're only allowed to complete the square if this coefficient is what, Charles? This coefficient right here, what does it need to be to complete the square? 1, okay? So to make this coefficient 1, okay, you can't just multiply through by 1. You have to pull out the 1. So we're very good with that. You're going to pull out the 1. Okay? It's not an equation where you can multiply both sides by negative 1. It's just one expression. Okay. Then what I'm going to do is now I've got a positive 1 coefficient. So now I'm going to complete the square. Okay? And what does complete the square mean? It means find the magic number. What's my magic number here? Remember, the magic number is always positive. It's not 4, 1. Do you see it? You take this number, divide by 2, and then square it. So that's 1. But if I add 1, I also have to subtract 1. The whole reason you complete the square is so that you can make this into a perfect square. So this becomes x plus 1 quantity squared minus 9. This is still, though, in all parentheses with a negative. That's good so far. Now I'm going to distribute the negative. I'm done completing the square. So if I distribute this negative, I'll get 9 minus the quantity x plus 1 squared. Okay, and now I'm where I want to be. This is equal to this. You can FOIL it, subtract it from 9. Okay, go to the closet, do that. And you'll see that this is exactly what you'll get. And so this new problem is dx over 9 minus x plus 1 quantity squared. Why is that useful? It looks like a what? Arc sine problem. Do you guys see it? It looks like an arc sine problem. It has a square root of a number minus an f of x. Okay, that is an arc sine problem. So if I suspect it is an arc sine problem, then what I do is I say this 9 must be a squared. This right here must be u squared. Okay, that means my a is 3. That means my u is x plus 1. Okay, I need to talk to you guys about this. If you're not practicing these problems, when you get on the test, this negative is going to freak you out. Okay, do you notice I just ignored the negative? Right, because the negative was built into the arc sine. Okay, so you can ignore the negative once you confirm that it's the format of the arc sine. Okay. Right here, what you do is what you always do, which is take the derivative of u and then solve for dx. Okay? It is a U-substitution problem. I usually don't call the arc sine problems that, but it is. And so what you do is you come up here and you replace two things. You replace your dx and you replace your u. It's a little tricky in these problems. When you replace your u's are actually u squares instead of u's. Okay, so this is going to be the integral of du over the square root of 9 minus u squared. Okay, and then this should be something that is on your pink sheet. Is it? Yeah, it's just that the a squared is a 9, but that's fine. A squared is just some number. So if this is on your pink sheet, then you know this answer is arc sine u over a plus c. Okay, guys, if you have a scalar, remember to remove the scalar, okay, before you write this arc sine u over a plus c. Then what you have is arc sine. I know my u is what? X plus 1. I know my a is what? 3, and there's my answer. Okay? Can you also write this problem down? Please write this problem down. This is definitely, I would say, I don't know, depending on what you have trouble with, one of the most missed questions on the test. Okay? Depending on, what you have trouble with. Okay, if I were to do this problem, okay, please write this down. Super important. I would make my u equal to x squared plus 4x plus 13. I would take the derivative of that and find that this is actually 2x plus 4. I would solve for dx, and this would be du over 2x plus 4. I would replace two things. I would replace my dx, and I would replace my u. So that gives me 2x plus 7 over u times du over 2x plus 4. I would pause for a bit, and I would say, do my x's cancel out? No. I know they both have two x's, but in real math, you guys good with this? In real math, the two x's don't cancel out. Back to the drawing board. And this is what I want you guys to see. What would make this cancel out? When I take the derivative of this bottom, I get 2x plus 4, right? So what do I really want up here? 2x plus 4, right? Had this been 2x plus 4, that would have been great. You know what? You want a 4 here? Put a 4 there. You want it, right? Do you want it? You want it? Okay, if you want it, put it. Put a 4 there. Okay, but if you put a 4 there, what do you also have to do? Put a negative 4. Right? If you put a 4, you have to put a negative 4, right? So if I rewrote this problem, isn't it really 2x plus 4, okay, I'm going to do a regrouping, plus 3 over x squared plus 4x plus 13. Do you agree I didn't change the value of the problem at all? Right? I'm just regrouping it. I want the 2x with the 4. I'm going to put it together, and 7 minus 4 is 3. Okay, everybody good? I didn't change the value of the problem. Okay? But what I really want in the numerator is just 2x plus 4. So I don't know if you guys see this, but it is a common denominator problem. Okay, it is. You can split this up into two different problems. Okay, don't split it up into three. I know you have three terms up here, but if you split it up into two problems, okay, what happens is this side is an easy LNU problem, and this side is actually an arctan problem, and you just add them together. Okay, that's the trick for this problem. Now, always try U-substitution first, though, because U-substitution might work before you having to do all this fancy stuff. Okay, but if U-substitution doesn't work, think about splitting it this way. Okay, over here, my u is equal to x squared plus 4x plus 13. My du dx is equal to 2x plus 4. My dx is equal to du over 2x plus 4. I substitute two things. Oops, I forgot my dx. Okay, remember this is two problems. So I substitute my dx and I substitute my u. So this on the left side becomes 2x plus 4 over u times du over 2x plus 4. Do my x's cancel out now? Why? By golly gee, they do. Okay, so this problem becomes the integral of du over u, which is really just ln of u. My u is x squared plus 4x plus 13 plus Charlie. Everybody good? That's the left side. I'm going to add that answer with the right side. On the right side, what you have to do is complete this square. This would be x squared plus 4x plus a blank plus 13. What's going to be my magic number there? Not 2, what is it? 4. Because you divide by 2 and then you square the 2. That's 4. If you add 4, you better subtract 4. Okay? The whole reason I completed the square is so that it can become a perfect square. Okay? So there's my perfect square. X plus 2 quantity squared. Okay? If you FOIL this out and add 9, you should get the same denominator here. You should test it. You shouldn't just trust me. Okay? This becomes 3 over the quantity x plus 2 squared plus 9 dx. And this was magical. Okay? Of course, the magic number would make it magical. Okay? What kind of problem could this become? An arctan problem. Okay? Why is it an arctan problem? Because my u squared is now x plus 2 quantity squared. My a squared is now 9. So u is equal to x plus 2. A is equal to 3. Okay? I go ahead and take the derivative of this. So the derivative is 1 and dx is du. I substitute two things. I substitute my dx. And be careful here. This one, I just substitute my u squared. That's all I substitute. Okay? And so what I get is 3, let's see, the integral of 3 over u squared plus 9 times du. Is this something that's on my pink sheet? Kind of. What do you have to pull out, though? The 3. Okay, you got to pull out the 3. Okay, so now this is on my pink sheet, and that's an arctan problem. So the answer is going to be 3 times 1 over a, arctangent u over a plus Charlie. Okay, so be careful with that 3. A lot of times students miss that 3. If you miss it, it's just minus 1 point. It's not a big deal. Okay, and then now you know your a's and your u's because you kind of forced it into an arctan problem. So this a is actually what, 3, right? This u is actually, is x plus 2. This a is 3. So if I rewrote this answer, it is just arctangent x plus 2 over 3 plus Charlie. And really, I need to add it with this problem right here, the front side. Does that make sense? Oops. Add it with this thing. And there is my full answer. How are you feeling? Okay, this is one of the tougher problems on your test. Okay, very doable. You just need to know how to manipulate this at the very front. Okay, all right, good luck on your homework.